In part 2 of this HCM example problem tutorial, we will now set up the freeway network in SwashSim and enter the traffic data. The first thing to do is to start a new project and then select the freeway facility type. And then in this screen, we're going to go ahead and add the different links that we need to recreate the example problem network. One thing to note, however, is that SwashSim is based on a linked node structure, which is different than the segment structure of the HCM methodology. Thus, there will not be a one-to-one correlation between the number of links in SwashSim and the number of segments in the HCM example. So again, the freeway facility configuration in the HCM methodology is comprised of 11 different segments. In SwashSim, this is going to be our link node representation of the network. So as you can see here, there are quite a few more links that we're going to end up entering than the 11 segments. On-ramps and off-ramps, for example, are going to be comprised of more than one link. And we'll come back and compare this schematic with what we enter in the program a little bit later. So we'll go back to the program and we will go ahead and start with our data entry. So first thing we'll do is add two basic links. We need to start with a basic link and we also need to end with a basic link. But for the on-ramps and off-ramps, those need to be inserted in between the basic links. So I'm going to start with two basic links, and then we're going to go ahead and click on this row here, and then we're going to insert an on-ramp link. And the sequencing of these links is important. And so the way that we have this set up right now is that this basic link here will be attached to this on-ramp link. Let's go ahead and add. So when we click the add, it's just going to add these basic links at the bottom of our table. If we click the insert, that will put it in between two rows. So add a couple more basic links. And now we're going to select this last row again, and we're going to insert an off-ramp. And then I'm going to add another basic link. And I'm going to select this last one again, and then I'm going to insert an on-ramp link. And then I'm going to add another basic link. I'm going to select this last one here, and I'm going to insert another off-ramp link here. And then I'm going to add a couple more basic links here. And I'm going to select this one here, and I'm going to add an on-ramp link. And I'm going to add another basic link, and another basic link. And I'm going to select this one here, and insert our last ramp, which is an off-ramp. So at this point, we've added all the links and link types that we need to recreate the freeway network configuration of the HCM example problem. And at this point, I'll go ahead and also save the work that we've done thus far. And now that we've saved the project, you'll see the file path and name displayed up here in this text box. And you can also click in there and scroll over to the right in case it's too long to see the whole name at one time. Okay, so at this point, we're going to go ahead and update some of the other information we need, such as the length and the free flow speed. So we'll go back to the example problem in the HCM, and the lengths are all given here. So we'll go back to SwashSim now, and I'm going to go ahead and revise these lengths. And for the on-ramp and off-ramp lengths, I'm just using an arbitrary length of 300 feet. I'm using 1,500 feet for the segment that connects to both the on-ramps and the off-ramps so that we can try and replicate that 1,500 foot influence area. So if you've entered all the lengths correctly, you should see the facility length display 6.0 miles. Now that does not include the on-ramp or off-ramp link lengths. This is just the length of the main line. So again, that 6 miles is from start to end here. We also need to enter the number of lanes. Number of lanes is shown here. And for that, we're going to scroll over a little bit to the right. Now, one thing that we need to recognize here in SwashSim is that the acceleration and deceleration lanes that are part of the ramp segments are going to be included on the basic links that connect to the on-ramps and the off-ramps. So we have to add an extra lane to create that acceleration or deceleration lane, and then we will change the length of those accel and decel lanes in a separate data entry location, which I'll show you shortly. So this basic link in row 3 connects to the on-ramp link, so we need to change the number of lanes there to 4. And then likewise, this basic link here connects to this off-ramp. So we need to change its number of lanes to 4 as well. And then the next one that we're going to change is going to be row 9. Again, this basic is going to connect to this on-ramp, but it also connects to the off-ramp. So we're going to change its number of lanes to 4. And then the next one is going to be row 13, because this basic is just downstream again, or it connects to this on-ramp here. And then the last one we need to change is row 15, because that connects to this off-ramp here. Okay, and now we need to set the lengths for those acceleration and deceleration lanes that we've added. And in the inputs here, in the HCM example problem, it indicates that the acceleration and deceleration lanes are 500 feet in length. So the cells in white are the ones where we can set those lengths. And this entry here actually corresponds to the weaving segment, and that's an auxiliary lane that connects the on-ramp and the off-ramp. So that's going to be the full segment length in this case, so that XL decel lane length will match our segment length, or our link length here. And then we need to set these two each to 500 feet. Another thing that we need to set is the orientation angle, and that's going to be the angle at which these links are displayed. And for a network that's going to run perfectly horizontal from left to right, that would be an orientation angle of 0. If it were running perfectly vertical from south to north, it would be 90 degrees, and so on. But we're setting this up just like the example problem here, to run from west to east in a horizontal fashion. And so we're going to set that first one to 0. Now for the on-ramps and the off-ramps, we also need to set those. For the main line, you start with the first link, and then the only other way that the orientation would change is if you created curved links, but we're going to just use straight links. But we also need to set the orientation for the on-ramp and the off-ramp links. And I'm just going to use 30 for our on-ramps and 330 for the off-ramps. And later we'll see how that gets displayed in the animation screen. So again, we're not going to do any curved links, so we're going to leave this column just set to no for all of the links. If we were to change it to yes, then these other fields dealing with horizontal curvature would become active. We also need to set our free flow speed. We're going to, in this case, just use measured free flow speeds. The default values are 65. But we'll go back and see what those are in the example problem. And 60 miles per hour for the main line, 40 miles per hour for the ramps. So we will change the main line links to 60 and the ramps to 40. The table display is doing some flickering because of the screen capture utility program that I'm using. Hopefully you don't see that screen or table flickering when you're using the program. Okay, so we've got the free flow speeds entered, and just for good measure, I'll go ahead and save our current progress. Okay, next we will enter the traffic data. And we're going to do that in this column, and the buttons that are highlighted in yellow are the places where we do need to enter that traffic data. So to revisit the HCM example problem, again, the traffic data are contained here in this exhibit. And again, we're just going to be dealing with time period 1. This should say time period, not time step. And so we're going to be using the values here in this first row. So we're going to have an entry flow rate here of 4,505. And we need to set our entry percentage for our respective fleet types. And so as you recall, we had 1.25% for smaller trucks and 1% for larger trucks. And I'm going to go ahead and just set the small auto to 50% and then the large auto to 47.75. So larger autos correspond to things like pickup trucks and SUVs and minivans. And so this number needs to add up to 100%, and this number should match or be plus or minus 1 of your entered value up here. Leave the vehicle arrivals distribution at random, and make sure you click Save Changes before you close this screen. And so if that was successful, when we reopen it, we should see the values that we previously entered. So next we'll do this on-ramp. And the entry flow rate for that is 450 vehicles per hour. And we'll use those same percentages as the example problem specified, that these percentages applied for all of the movements: mainline, on-ramp, off-ramp. So that looks good. Save the changes. What we're going to do now is we're going to finish the on-ramps, and then we'll come back to the off-ramp traffic data. So we're going to go to row 8 now and select that on-ramp, and the entry flow rate is 540. Checks, save changes. Then we're going to go to row 12. And that entry flow rate is 450. Save changes. Okay, so now we can go back to our off ramps. So I'm going to go back up here to row 6. And let's go back and check our Excel spreadsheet. And so the percentage that we calculated from this was 5.45. The program just allows tenths of a percentage, and so we're just going to go ahead and do 5.4. If I show a little more precision on this, that's what we have. And again, I'm going to input my vehicle type percentage splits here. And what we see in this last column here is the absolute exit percentages for each vehicle type. And again, this column needs to sum to 100, and this column should sum to the value entered here. In this case, you can just hit the close button and it will save your values that you entered. So the next one we're going to do is going to be row 10. And again, looking at our Excel spreadsheet, we had 6.9% there. And again, enter our vehicle type split. And that checks. And then the last one is going to be row 16. And that was 5.1%. And that checks. And again, I'll go ahead and save our work to date here. At this point, we should be ready to run the simulation, but I just want to point out a few other items before we do. On the far right are the buttons that we can use to access the detector setup. So we can add detectors to any given link and any given lane within the link. For this example problem, we're going to use the link-wide performance measures, so we don't need to set up any detectors. The control point columns you see here are only used when you have curved links, and those values are initially calculated automatically by the program, but the user can edit those to fine-tune the curvature, the horizontal curvature. Also, this example problem uses level terrain, so we left the grade as 0. These columns over here, the upstream and downstream node ID and X and Y coordinate start and end points, these are all calculated automatically by the program. That's why they're colored in gray. The user doesn't need to enter values for these data items. You'll notice that these values here all match what are shown in the schematic here. So now at this point, we'll go ahead and run the simulation. And to do that, we click on the simulation button here. And that will bring up the simulation control panel. And we'll talk about running the simulation and getting the output results in the Part 3 tutorial video.